So good morning, everyone. Thank you for turning up on this morning, a session which we had a great turnout yesterday, and you've beaten them. So thank you very much for that. I'm sure you've just come from the keynote session and you still want to sit down. So I appreciate that. So my name's Simon Pamplin. I'm the technical director for Silver Peak and EMEA. We're specialising in software-defined wide area networking. And today I want to talk to you about why it is that you need to consider some key technical differences when you're looking at how you migrate applications to the cloud and how your wide area network can facilitate that. Now, before we start, you'll all have seen you've got a form on your chairs. I hope you've all got a form and a pen. So throughout the presentation there'll be a number of answers for the questions that you've got on the form, and we'll be doing a prize draw or giveaway at our stand later on, assuming you get the correct answers. So your job today is to fill out the forms and hopefully get the correct answers. My job is to try and remember to give you the right answers in the presentation and not forget them. If I do forget them, I do take bribes, so that'll be absolutely fine. So before we start, can I just have a show of hands? Who here is an end user with a wide area network? Right, excellent. Okay, good. And who here is from service providers, managed service solutions? Okay, and what do the rest of you do? Okay, another thing. So who here is a fan of old cars? I love old cars, and I recently went to the Goodwood Revival and saw lots of old cars. And it made me think, because when you look at the old cars, the amount of effort it takes to start one of these things, to configure it, to get it to actually move, changing the timing, changing the points, etc., to get this thing to actually start, to go from point A to point B, is immense. The thing will still get you there, and it will still have planned a route using an old-fashioned map, but the amount of effort to do it is huge. Now, I don't know about you, but I get into my car and I press a button now to start it. I don't even turn a key. So the progress that's been made is dramatic. But then you look at the likes of Google, and what Google have done is taken the whole stress of starting the car, driving the car, choosing the route, being the most optimal direction out of the way, and provided a vehicle that achieves what the end user wants, which is to go from point A to point B in the most efficient way. And when you think about it, we've been in a similar situation with wide area networks for many, many years. They require a lot of highly skilled people to make a lot of individual changes at endpoints within the network to hopefully achieve what you want at the quality of service you want at the performance that your applications demand. So if Google can make that change so dramatic in the car industry, why can't we do a similar thing in the wide area networks? And that's pretty much what we achieve with software-defined wide area networking. We're taking the complexity out of building complex networks, and we're putting the control back in the user so that the user can define a network architecture or performance based on the application rather than just whether this network link is up and what the latency is. So it's a completely different way of thinking about how you construct a network. And I'll show you in a minute the dramatic improvements both in performance and cost savings, more importantly, that some of our customers have found by deploying these solutions. So when you think about the wide area network and when it was designed, you have to remember that back when it was first set out, people had applications based in data centers. The whole point of the wide area network was to draw application communication back to the data center to run maybe an Oracle database or something and deliver it back out to the clients in the remote locations. It was perfectly good for what it was trying to achieve, but things have changed. We're now deploying lots of applications that are no longer in data centers, so arguably you could say that the wide area network of old is no longer fit for purpose. I don't know about you, but I spent my life in SFDC and various other cloud-based applications, and if that was a traditional approach, I'd still have to go back into the data center to then go back out to a cloud application, to go back down to the data center, to go back out to me, when I could use a broadband link local to me and just go straight out to the network and get much more performance. So the WAN architecture really isn't designed for cloud applications. We had a customer that I was speaking to the other week who said, I understand my network completely, I'm purely broadband, I don't have private circuits, but I have developers making new applications and I have no visibility of what that application is going to do to my network performance. I have no way of seeing the impact before they release it. And once they've released it, it's too late because I then have the problem and I have to play catch up. So network visibility is also an issue in the way that traditional networks were set up. Ads change and moves Who here has had a problem or spent ages waiting for a new circuit to be deployed or a change in the network to be done? It takes time. It's not because the service providers have a long list of things that they're doing, it just physically takes time to achieve. But what about if you could put that control in the user's space? What about if an application or a new location needed to be set up? It could be set up and be online very quickly without having to wait maybe 3 months for a circuit to be provisioned. And users have escalating expectations. I mean, I at home have 80 to 100 meg broadband to the house. I get fantastic performance most of the time. I go and work in a business office and I might have a 5 or 10 meg connection shared by 150 people. But that 10 meg connection was costing £2,000 a month, whereas my 50 or 80 meg at home is costing me £20 a month. The imbalance is there. It's just if we can make the broadband perform like a private line, then the cost savings are dramatic. And that's what we're starting to see. We're starting to see businesses looking to see if they can take advantage of the newer technologies that are becoming more robust and treat them like business-grade circuits. And that's really where software-defined wide area network comes in. So people are now saying, well, why can't we use the public internet? And we're talking consumer-grade internet here. We're not talking about direct-to-internet or business-grade, as they call it, which is going to cost you roughly the same as an MPLS circuit. What about if you could use the same consumer-grade circuit at the consumer-grade prices and make it perform like a private circuit? I mean, that has value. But there are concerns at the moment. The internet has performance and reliability issues. We all know that. Occasionally things stop working, or it takes longer to do a file transfer, or it's not quite as reliable as a private circuit. And how many people have been concerned about security over the internet? Who's looking at my banking details? How do I protect the traffic into a completely public network? How do I ensure that all of my business data is as secure as if it was on a private circuit? And again, visibility and control. As soon as it goes into a public network, have you lost control? Have you lost visibility of where it's going and what it's doing? Lots of questions get risen, which is why people have shied away from using the public internet. And another thing that still makes me smile is that people do often have a private circuit and broadband, but they have them as an active-passive solution. So they're paying twice and they're getting one of the performance, 1x of the performance. And that's usually because it's actually quite difficult to do active-active with policy-based routing and various other solutions. To configure it and make it viable for adds, change and moves without taking up lots of CCIE qualified people's time is very difficult. So people tend to have a primary circuit, and when that primary circuit fails, only then will they fail over to the secondary broadband circuit. But what about if you could do that active-active all the time and you didn't have to do the complexity of managing how these circuits balance the data packets going across? So we believe that we can take a public internet connection and we can make it as performant as an MPLS circuit. We reckon we can take multiple service carriers and we can put the control back into the user's hands. We also think we can make endpoints come up quicker. So if you've got a branch rollout or branch locations, be that a small office or a physical branch, if you're in retail, for example, we can bring up that solution in a matter of minutes rather than days, weeks, months. And it makes a massive difference on time to market, and it opens up a whole load of new possibilities for that business. But the main thing is that we can take a consumer-grade circuit and we can condition that path so that it behaves like a private circuit. So I've mentioned SD-WAN a number of times. So again, show of hands, how many people actually know what SD-WAN means and what SD-WAN is? Anybody, or am I preaching to the converted? One down the back, excellent. So software-defined wide area network honestly means different things to different people. You go and talk to multiple vendors, they've all got a different version of it. But there are some fundamental things that SD-WAN tries to achieve. So it's trying to simplify complex networking. It's trying to simplify how you provision a circuit. We're trying to make sure that any circuit that you do provision is entirely secure. So you could put PCI or payment card information down it. You might have local government solutions that require encryption. It needs to be secure. It needs to take advantage of all of the paths, the data circuits that you have available to start giving you the cost benefits and the performance benefits. So it needs to be able to do that without you having to make individual choices on a day-by-day basis as to which path you're going to use. Obviously it needs to be reliable, otherwise why would you do it? And you need to be able to manage this centrally. So a central orchestration layer that allows you visibility of your entire network from one pane of glass, where you can drill down into individual circuits or filter them based on the type of application, is one of the key requirements that people are looking to for software-defined wide area networking. Now, we agree with that, but we believe there are 4 additional pillars, look on your forms, 4 additional pillars that need to be wrapped around software-defined wide area networking to achieve these end games, and which is what makes the Silver Peak solution that much more performant and secure than our competitors in the market. So we need to improve all of the connectivity. We have additional licenses that we can add to our base SD-WAN license called Boost and SAS Acceleration. So Boost gives you wide area network acceleration, so TCP acceleration and data deduplication across the network. Allows you to transfer far more data over a certain amount of bandwidth. The SAS acceleration allows you to connect to the most effective endpoint to be able to jump into the cloud to that particular cloud application and reduce the latency that you have. The visibility and control, obviously if you're involved in security on networks, that's key to you. We need to be able to look at the first packet and identify exactly whether that application is one we're happy to allow onto our network or whether we drop it. And security, we've talked about, it needs to be encrypted, it needs to be secure. But the other key thing is that we don't want to be the next firewall provider. We don't want to be the next Checkpoint or Palo Alto, etc. So we have relationships with these organizations such as Fortinet, Zscaler, Palo Alto, Checkpoint, where we can link into their services in the cloud and provide you a way of allowing local endpoints to break out to the internet, but still be secured by a firewall without you having to go and buy yet another box at each endpoint location. So on the performance side of things, we talked about the multiple types of connectivity. So we can blend all of the connectivity you have and virtualize it, and then choose which is the most effective route. And I'll show you an example of that in a minute. We can do seamless failover. We can do sub-second failover between these connections so that your application believes the connection is still up and still viable, yet we've now sent the packet down an available route. And we can do this with quality of service that you define for the application at the top level. And again, as I said, WAN optimization, which is what Silver Peak in its history, so we've been around for 12 years plus and spent at least a decade doing very high performance WAN optimization. We have that capability as a licensable feature of SD-WAN, so you can have the best of both worlds in one product. So to give you an idea of how we do this, we have an application-focused approach, and we build templates that allow you to define what is the quality of service, what's the level of latency my application can support, what do I want to do in the event of a failure, etc., that we define up front. And based on that information, our devices will build the required network. That might be a full mesh virtual VPN, it might be a hub and spoke, it might be any type of architecture that's required to achieve that level of optimization. For example, you might have SAP applications or VoIP applications that absolutely have to have a guaranteed SLA, so you're going to stick them through the private circuit. You might decide that if that private circuit fails, that it's better to drop the packet. No phone call is probably better than a garbled phone call, but it's up to you, it's your choice. You could decide to fail over that voice over IP connection to a broadband circuit if you decided that that was going to be sufficient for your needs. Same with SAP. You might have other solutions where you say, I actually want to blend some of the packets, so I want to put most of it down the primary circuit, but if that primary circuit is being required for my voice application, I'm happy for the packets to fail over onto an alternative circuit. And you might still have other ones that want to go through the lowest latency or any other type of description that you decide for that application. So it's very, very flexible, but it's from an application focus rather than how much network latency have I got, what's the loss level on this link, because if the application is having to do lots and lots of retries, your loss in latency is irrelevant. The application is still performing badly if it's having to continuously send these things. If we can stop it sending or doing the retries and reduce the latency that way, we can absolutely improve application performance. So I mentioned the type of connections we have. So typically we'll have a very fat pipe from the internet with consumer grade. May not be the highest quality, may not be the highest reliability, but it's certainly the big bandwidth. You might have an MPLS circuit of maybe 2 10 meg costing you quite a lot of money, but with a guaranteed SLA. And you can also plug in things like 4G LTE dongles into the devices, so if you've got a location that only has a radio network connection, you can still connect it into your branch while you're waiting to provision maybe a broadband, or while you're waiting for a DSL, a MPLS circuit to be provisioned. So the time to market advantage of doing these solutions is huge. Now we have the ability to bond these tunnels together, so instead of having, as we had here, maybe a 10 meg MPLS circuit and a 200 meg broadband, we can turn that into a 210 meg link as far as the application is concerned. If part of that tunnel fails, sub-second we can fail over to the other part of that tunnel quite happily. And again, this is all under your control. You can describe exactly how you want this failover to happen. And if the tunnel, both components fail, you can always fail over to 4G if that's something you want to do. But the flexibility is there, and it's flexibility that you've never had with traditional wide area networks. Now you're probably thinking, if I go and fail over to a really lossy network, how on earth am I going to guarantee performance in applications? So we have a couple of technologies that I think are key to the way that Silver Peak achieve this. So we have forward error correction and packet order correction, and these are the two key things, visual forms, that will help you make a bad circuit look really good and condition that path. What forward error correction does is it sends a parity packet down an alternative route if it sees that its primary route is becoming too lossy, above a threshold that, again, you've set. It's dynamic, so the more lossy that link becomes, the more parity packets it will inject to an alternative circuit. We have the ability to rebuild at the destination end any packets that are missing from the parity packets. What that achieves very simply is that we don't have to ask the application to do a retry. So instantly your performance is improved purely by the fact that we're not asking for lots and lots of backwards and forwards communication. We have one connection, one stream of packets that are delivered to the application or the end user as they would expect it on a perfectly clean circuit. But also that raises the question of, if you have packets going down diverse routes, they're obviously going to be out of order, or they have the potential to be out of order, which would normally mean another retry. But we sequence every single packet that goes through our device, so we know what number order it should be in. We can resequence them at the destination end, deliver them to the application, again, as if it was a completely clean circuit. So those two things are fundamental to the way that we can condition circuits, and we can make this an improved solution. So I mentioned on the visibility, we do deep packet inspection on the first packet. We can identify an application, a destination, a port, or a user-defined application type, and then you can build a template based on that for a quality of service or a performance level. So again, it gives you information about what's on your network that you've never had before, and our orchestration layer will give you lots of nice statistical graphs around that. On the security, we do everything through 256-bit encrypted tunnels. So everything is secured and separated. We have PCI compliance. In fact, our boxes are also FIPS and CT certified as well. So if you're doing any local government that requires that sort of level of security, we have that certification as well. And as I said, we have technology alliances with various people who are doing cloud-based firewalls as well. So again, if you want to do local breakout at the branches, we can do that in a nice secure manner. As more and more of these services come onto the cloud, we do service chaining. Again, we do partnerships with some of the organizations you can see up there to allow us to take advantage of some of their capabilities without us having to reinvent it. So it's an extremely flexible solution. Now, just to give you a pictorial guide, so what we do is we virtualize the entire transport, and then we define our templates. So in this example, we've decided we've got a voice over IP solution. We've got it tagged on a voice VLAN. We've decided this has to be the highest availability, highest performing solution. So we're going to stick it on our MPLS. Because we've said we want it on high performance, high availability, it creates a full mesh automatically for us. So we don't have to define that. You don't have to create the VPNs. And that will give you the performance level that you want. But we can layer other ones on top of that. So we can layer up to 7 of these on top. So for your one network infrastructure, we can layer multiple virtual networks on top. And you can go through, maybe your enterprise applications have a different requirement. In this case, there's 2 data centers, so dual hub and spoke. It does it automatically for you. Right the way up to, if you wanted to provide a guest Wi-Fi as a very basic, non-resilient solution, it'll do that. You create these policies centrally, and then you push them out to the edge devices. You don't go to each individual device. You can do if you want, but you don't need to, and which means you get a business-grade set of policies that are consistent across your business. Device is both in a virtual solution and a physical solution, so we can deploy in any of the hypervisors out there, or in a lot of our branch locations or remote locations like the physical hardware, so they can point at it or label it. We can do both of those. It comes in various sizes, so our extra small can deal with anything up to 200 megs of bandwidth. The very large one will do 10 gigs. And the amount you pay is a monthly payment based on the bandwidth that you're trying to put through it. This is probably my favorite view out of our central orchestrator. So what you're seeing here at the bottom is an internet connection. In the middle, you're seeing the MPLS connection, and the little spiky graph is the loss that we're seeing. The brown sections, or orange on this, is the threshold that you've set for a brownout condition, where you consider it's no longer the right quality for that application. But because of forward error correction and packet order correction, the very top graph is what the end user sees and the end user application sees. We've managed to remove virtually all of the loss in that network by blending those two other networks and doing the error correction and order correction, and given them a completely clean, much bigger bandwidth solution at a dramatically reduced cost. If you start adding boost to this and do the network acceleration, and these are based on real customer figures, you can see that the light blue is the traffic that was going over the local area network, but because of the data deduplication and the TCP acceleration that we can put in place with boost, the dark blue is what's actually traversing the wide area network. So again, your fixed network bandwidth and your wide area network can now be utilized for far more, because you don't need to transfer as much data to achieve the same result that you did in the past. And if we look at the blended solutions from when they were MPLS on their own through to if you went to dual broadband, which is what, as I said, one of our current public references is doing globally, the dramatic increases or decreases in cost per month is huge. So they're getting 90% reduction on their network connectivity globally. They're running voice over IP, they're running SAP, they're running CAD solutions, Office 365, they're doing local breakout within the solution. It works for them. So it really means that we're giving you business agility. We're putting the control back into the network management team. We're allowing it to perform with a network that's based on a business requirement for an application quality of service. And we're doing that in a way that allows the existing infrastructure to be reused, but augmented with newer technologies such as broadband and 4G. And really Silver Peak is where this all comes together, with our heritage of WAN optimization and with being the market leaders in software-defined wide area networking. We can now make very lossy networks perform like a private circuit at dramatically reduced cost. If you want to know any more, we're on J12, so be happy for myself or my colleagues to talk to you in more detail about it. Please fill out your forms, as we've got some prizes to give away on the stand, assuming you've got the right answers and assuming I remember to tell you the right answers. But other than that, thank you very much for your time.